Hello. So let's wait for some final people to come in and then we can start. Good morning. Thanks for being here. Nice to see so many people actually showed up. Maybe you had a party last night, but still you're here. So that's good to see. Today's talk will be web applications of the future using TypeScript and GraphQL. So besides React, I think these are my two favorite technologies. Although GraphQL might be my most favorite technology, but who knows? It might change in the future. So who's this talk for? So before I'll be explaining what GraphQL is and what it can do for you, or how TypeScript could help your React application, let's see why you actually maybe need a type system. So I always like the question, what is a date? So a date could be an actual date. So maybe it's December 7th. I think today is October 1st. So October 1st is a date. But then this dried fruit is also a date. And there are probably much more examples of things that could be dates. So you can also spell the word date with the dried fruit. And these are all examples of date. So let's imagine a JavaScript application or a React application. And you maybe already find 3 different ways to define a date inside your application. And maybe there's also a different way to define a date like you see in the Disney movies. So this could also be a date. And if we go to a JavaScript application, these can all be examples of dates. So maybe people are using the actual date object or method in JavaScript. Maybe you define your date as a string. Maybe you use timestamps. Maybe you use something else. I actually saw projects where people were using an object to define fields for like the day of the week, actually the week, maybe also the month and the year. So the different way to do dates in JavaScript, in React, in programming, and also in life. So that's why you actually need a type system. So how many people here today are using TypeScript in the React app? Nice, so that's at least half of you. So that's great. And if you're not using TypeScript today, it's completely fine. But if you are building something for users, and you actually don't want to wake up middle of the night feeling afraid that someone will actually break, or will get like a client-side error, use a type system. And that's another reason I like GraphQL, as I will tell you later, because it has a type system while it's also an API. And that's something you don't typically see for REST. You see, plenty of use cases for REST where people are creating bizarre ways to get a type system for REST APIs, but GraphQL has a type system built in, as I will show you later. So let's see if we can get the slides back. Yeah, there we are. So a little bit about myself. My name is Roy. You might have seen me on Twitter. You might have seen me yesterday. I work at StepSam, which is a GraphQL as a service company. So if you want to create a GraphQL API for your data sources, you can check it out. I also like to teach people how to use GraphQL, TypeScript, and React by giving workshops, writing books, and speaking at conferences like today. So if you'd like to know more about any of the things I tell you today, go to YouTube and find me and see some of the videos I created. But most of all, just ask me any question if I walk around, because I always like to help people figuring out how to use new stuff. So what do you already know about TypeScript? I guess as most of you have been using TypeScript, it's pretty much. But if you haven't used TypeScript, I'd like to help you as well. So let's have a small look at what TypeScript is and what it can do for you. So TypeScript is what they call a type superset of JavaScript. And if you don't know what a type superset is, I didn't know the first time I was looking at TypeScript as well. So I looked it up on the internet, and actually I think Wikipedia gave me an ID. They even give you a pronunciation for it, so please correct me if I'm wrong. But in computer science, a superset is a programming language that contains all the features of a given language. So this means that if TypeScript is a superset of JavaScript, it has all the features that JavaScript also has. So you can use your variables with const, you can create mutable variables with let, you have functions, you have all the cool things you have in JavaScript, but they will be extended or enhanced to include other features as well. And in the case of TypeScript, this is a static type system. So when you write TypeScript instead of JavaScript, you can enhance your code by writing types. And actually doing something cool, so they might be introducing types into JavaScript as well. There is a RFP for it and maybe even a prototype. So maybe we don't even need TypeScript in the future anymore, but let's find out. So TypeScript is nothing more than a type superset. And I say nothing more, but actually it's a lot more, as you will see later today. And it also compiles to plain JavaScript. So maybe you know, maybe you don't know, but your browser actually can't read TypeScript. You can try writing JavaScript in your developer console and it will work. Try writing TypeScript and usually you don't. Maybe you're using some funky new browser, but usually it doesn't work. And that's why TypeScript compiles to JavaScript. So if you're writing your code in TypeScript and you actually compile it and send it to your browser, it will be JavaScript. So this is an example of some TypeScript code on the left. And as you can see, I've used different ways to define things in there. I've defined a type called fruit. And I also have an array that is a list of fruits. So when I iterate over this array, I need to define the type because otherwise TypeScript might give an error. And as you can see, I'm taking an array with objects and I'm transforming it into an array of strings. If you do this in JavaScript, you actually have no idea if things are working or not. You don't even know if the field name is existing. But in TypeScript, you know because you do a check for it, and if it isn't, you probably get an error somewhere. But if you send this to the browser, it will be just JavaScript. So the type checking won't happen in your browser. It will happen whenever you compile your code and make it ready to ship to your users. Because you need it to be readable for the browser. And you can even define how you like this code to be transfiled. So you can also say, I want to have ES 2015, maybe you like older versions, maybe you have newer versions. So these are all things you can define when writing your TypeScript code. But the most important thing to understand is you only write the codes, you only type it whenever you're writing code. So whenever you send it to your browser, it will be just plain JavaScript. And also, which is important to know, it uses the latest ECMAScript features. So TypeScript is a popular one, it keeps updating all the time. So you need to make sure that, you actually don't have to make sure because TypeScript does it for you, that all the new latest ECMAScript things are in there. So I think 2 years ago, we saw some cool updates with like nullish coalition and some checkings if variables exist or don't exist. All these things are in TypeScript as well. And then I already told you this in the beginning, but do you know what else has types? So what else has types? Can someone tell me? It's GraphQL, right? So you probably could have guessed this from the title of this talk, but GraphQL also has types. So just as TypeScript has a type system, GraphQL also has a type system. So what do you already know about GraphQL? Are there people that know GraphQL? Okay. Not so much people have been using TypeScript. Are there people actually using GraphQL in production? Okay, that's good to see, good to see. Well, hopefully more will follow. I gave a workshop 2 days ago. So if you haven't been there, try and catch me at any of the other workshops because it is a nice technology as I will show you today. So GraphQL is a query language for APIs. People often think GraphQL is a framework or it's a JavaScript library, and actually it isn't. So GraphQL was first invented at Facebook by 3 people that were sort of frustrated by the way they handled APIs in different clients because Facebook was getting popular in like 2012 when they actually invented it. And they figured out it was quite hard to use your APIs in different clients and also use the same API to ship to different people all over the world. Because maybe your social media app is growing in Africa where the bandwidth is different than from the west coast of the USA. So they came up with a new query language for API that was more dynamic and also gives more freedom to the developers. And I think when they designed GraphQL, the most important reason was to save bandwidth. But I think today, what do you see people using GraphQL for? It's most of all developer experience. So GraphQL is not a framework, it's a query language for APIs. So what does this mean? If you look on the left side, you can see a GraphQL query. So how GraphQL works, you have schemas and you have queries and other operations types like mutations and subscriptions. But it all starts with a schema. And you can use this schema, which is basically the type system, to figure out which queries you can send to the GraphQL API. So with a REST API, you're maybe sending GET request, you may be sending POST request or PUT request. In GraphQL, you always send a POST request, and inside the body of that request, you will define what your operation is. And your operation can be a query, like you see here, which is for reading data, but it can also be a mutation or subscription for other types of data. So if you look on the left, you can see my query, and I'm requesting several fields there. So my operation is called GitHub user. So this is a GraphQL API for GitHub. I define a GitHub username, and based on the username, I'm requesting information like the bio, followers, and also the name of the followers. And if you look on the right side, you can see the response, because GraphQL will always return JSON. And the JSON you see on the right side, it has the same structure as you can see on the left side in the query that we sent to it. And the information for this can all be found in the schema, which is basically the type system of GraphQL. So GraphQL is all about tell me what you want. What you really want, you're actually going to be getting this data. So one of my biggest frustrations with REST is that you send a request to a REST API endpoint and you get JSON. But before you send the request, you usually don't know what information you will receive. Maybe you have to try it out first in Postman, in your browser, or maybe just by using curl. You don't really know what the data is you'll be receiving. While with GraphQL, you always know the data you're getting because you define a query and you also have the schema to fall back on. And GraphQL does something else quite different than REST, or basically than most other API specifications. It offers you a single endpoint for multiple resources. So imagine you're querying your database and you do a select all on one table. That's usually what a REST API does. You just get information from one table and not from the others. With GraphQL, you have just one single endpoint that gives you information about all your different database tables or REST APIs, microservices, whatever you're connecting to your GraphQL API. Because your GraphQL API doesn't really care where your data is coming from, it only cares about the data that's given to you as a front-end developer. So this means that if you would look on the left side, we have another query. And this is a GraphQL version of the Twitter API. And maybe you've been using the Twitter API, maybe you haven't. But whenever you're searching for tweets in the Twitter API, you cannot get information about the user other than its ID. So if you want to get more information about the author of a tweet, you would actually need to send a separate REST API endpoint request to get the information about this user. With GraphQL, you typically have all this information in one single query. So it means you can define nested relationships, and whenever you define that nested relationship, it will get this data for you, and depending on your API implementation, this information won't be queried unless you specify whatever data you like to get. So if you're building your GraphQL API, you typically have separate resolvers, which are like functions to get data. Doesn't really matter for this setup. But it's good to know that if you don't request these fields, typically your API won't get these fields from your underlying services like your REST API or your database. So you can define nested relationships. You can even define them like for an infinite amount of time. So you can maybe, if you have the author and the author will give information about tweets, you can get the author of the tweets again. So it can be dangerous. You want to make sure that you're not in this infinite loop of getting data. So that's why building GraphQL APIs could be harder than building a REST API. But most of all, and this is what I wanted to highlight to you today, GraphQL is based on a type system. So I already told you a bit about the schema. So the schema is at the core of every GraphQL API. And in the schema, you can find all the types for your queries and also the response types. And if you're used to TypeScript, you probably will recognize some of these, and I will highlight the differences later. But if you would be introspecting a GraphQL API, you can either doing this by sending a query to it, but you can also open Graphical Playground, or any of the other playgrounds that are available for GraphQL. Because at its core, GraphQL exposes a schema. And the schema can be read by interactive playgrounds, in which you can find all the type definitions for the fields that are available in your API. So this is an example of a graphical interface. And in here you can already see that if you try to get more information about a type, you can also find the types of all these fields. So you define high-level types, and then you have types for fields as well. You can even make them relational, as you'll see in TypeScript as well. So in that case, they're pretty much the same. So let's compare the two type systems. So we know TypeScript has a type system, of course, and it's a type superset of JavaScript. And we also learned GraphQL as a type system and is a query language for APIs. And let me tell you why it's important to combine these two things, to actually use them inside your React application to get something we call end-to-end type safety. But first, let's compare the two type systems. So on the left side, you can see TypeScript. It probably looks familiar to you. You can see we have some types. We have an ID in the title, which are like a number and a string. Then we also have a relational, or like a parent-child relation with categories. So you can see categories is an array of type category. And we also have reviews, which are optional. And if you look on the right side, you can immediately see some differences. So the first difference you may be seeing is that all the type definitions, or at least the name of the types, they use an uppercase for the first letter. So we don't have a lowercase string. Instead, we have a string with also an exclamation mark. And this exclamation mark is there for a reason. But before, they both have basic scalar types. So in TypeScript, you maybe call them basic types or everyday types. There are multiple names for it. In GraphQL, we call them scalar types. So scalar types are the basic ones. We have 5: integer, string, float. These are all examples. We also have Boolean. And the ID string is also there, which is kind of a funky one because it says ID, but it's actually a string. So sometimes you see people using both, but both have basic scalar types. And as I showed you, they also have relationships to other types. So the same way as you define relationships with other types in TypeScript, you can also define them in GraphQL. Except the notation is a bit different. Instead of using the square brackets for an array behind the type, you actually put the type inside of it. And then the final one is the exclamation mark or the optional required flag. In TypeScript, everything is required by default, which is kind of handy because it gives you, at least it lets you know whatever data you can expect and can't expect. And if you want to make something optional, you need to put the question mark there. In GraphQL, it's the other way around. If you don't define something as required, it will always be optional. And this is because GraphQL, of course, is used for APIs, and APIs might have different use cases. So maybe someone is using the GraphQL API to fill a mobile client in which they use maybe only short descriptions and short titles, while someone else is using the same GraphQL in a client that's on the web, in which you maybe need longer titles and longer descriptions and maybe more information in general. So GraphQL assumes everything is optional unless you define it's required. And then even for things like you see with categories in which you have a array return, there are more ways to define if something could be null, it could be like an empty array, it should always be a filled array. So the options are actually, quite big. So how to combine TypeScript and GraphQL? And this is the live coding part I'm going to be showing you. So you can actually combine the type systems of TypeScript and GraphQL inside your application. And you can probably already guess that it can offer you some large improvements, because maybe you're already using TypeScript and you're using a REST API endpoint, maybe you're using GraphQL API endpoints. And one thing that frustrates me a lot is that every time you change something in your API or you change the request you're fetching, you also need to change the types that you're using inside your components. And this is something, we live in 2022, it's almost 2023, like 3 more months to go. It should be easier like this way. And for this, we'll be using GraphQL Code Generator, which is a CLI that helps you to get your GraphQL schema and transform that GraphQL schema into TypeScript types. So it's a CLI tool. Personally, I'm a huge fan of CLIs. I try to keep away from GUIs. I hope you do too. Because CLIs just give you more freedom as a developer. You can use your terminal to create something out of nothing, and the CLI will usually auto-generate some code for you. So with GraphQL Code Generator, we can create types from a GraphQL schema. And for this, of course, you would need a GraphQL API. And if you remember both the type systems, you can see they're pretty much the same. So if you would have a GraphQL API, like you see on the right, which in example has products with titles and thumbnails, you would also need to define the TypeScript types that also have the same information. But by using the GraphQL schema as a sort of truth, so whenever you start building a React application on the front end and you have a GraphQL schema on the back end, what you'll be doing is you'll be using this GraphQL schema as your source of truth. So when you try to get end-to-end type safety, it all starts with your GraphQL schema. If your GraphQL schema is there, you can create the types for it for your front end. So actually try and switch these around. Instead of using TypeScript on the left, we will be using GraphQL on the left. Because GraphQL will be your single source of truth for all the information that flows into your application. Maybe you have other things in your app, like configuration files and these kind of things. That's all fine, they adjust for your application. But when you're working with data, the GraphQL schema should really be the source of truth for your app. What I see people doing with REST, in example, is often normalizing things that come from a REST API, because the REST APIs are less flexible. So with GraphQL, you can also delete all that code that is normalizing stuff, bringing together endpoints, because we already saw GraphQL is a single endpoint for multiple entities. So we're going to be generating TypeScript types out of our GraphQL types. It looks a bit like this. So if you see a GraphQL schema on the right, you can see the types for it on the left. So what GraphQL Code Generator does for you, it defines the basic types we have in GraphQL, which are scalar types. You can see them on the left. So there are 5, they're ID, string, boolean, int, and float. And they would translate to these types in TypeScript. So an ID would be a string is a string, of course, boolean is boolean. And in GraphQL, somehow we have 2 ways to define a number. So these are either integers or float if you maybe work with pricing or any other comma-separated numbers. So if you would match these things and we try to create the types for a product, you would define them something like this. So we create a type, you could also create an enum maybe, and in there you would define that ID is an integer, title is a string, thumbnail is also a string, but you actually try to compose them for the TypeScript types. And this is something you can imagine if you do this by hand or manually, it will be quite a lot of work. So we'll be using GraphQL Code Generator to generate this for us. So we're going to be mapping basic TypeScript types, and we also be keeping relationships aside. So let's try it out. I build a small React app. I think it says Next.js, but actually I use Create React app because it was just easier for my use case. Then I will be using GraphQL Code Generator, which was the CLI I mentioned. And then just see what kind of pure magic we will get out of this. So if I would be going to my editor. So this is my editor. I've built a small React application. And also I have a GraphQL API. And if this page looks new to you, it's actually the new graphical interface. So we've been working with the old graphical for quite some while. But luckily there's a new graphical which looks quite modern. So this way I don't have to tell people GraphQL is the future while showing them a UI that's like 8 years old. But the new graphical is kind of cool. And in here we're going to be sending, you can actually send some queries. But first let me see what my schema looks like. So in the slides I used the example of a product. What actually we'll be doing today is using a sort of Hacker News clone. So what we have is, we have articles. We can have single articles. We can have a list of articles. And in this graphical interface, you can introspect the schema. You can see what types are available. So you can see there are quite some types. So what I've done to create a GraphQL API, I took the practical dev. So if you write articles in practical dev, you maybe know they have an API. I used to be using it for my portfolio website quite some time. And actually transform this into GraphQL using StepSend. So I have a StepSend GraphQL API running here. And with this, I can just query a REST API using GraphQL. So if I would like to get a list of articles, I can just define them like this, get their ID, get a title, and I run this query. So this will give me information. These are the latest articles coming from Practical Dev. So maybe if some of you wrote something this morning, you might see it ending up on the list. So this is the query I'll be using. And what I will be doing in my code, so this is my GraphQL API, this will be my single source of truth. And in my React app, which is this code, and I hope it's readable, let me close it a bit. It's the only thing I'm doing here is just looping over the information that's coming from the GraphQL API, and I'm rendering it in a UI. We can start it so you get an idea what it looks like. So this will just start my sort of Hacker News clone. It's quite a basic UI. You can see it has some information. The upvotes are constantly changing because I thought let's do something cool. You can see some things about Hacktoberfest. You can see people writing other kinds of articles. And this is all live information. And this is a GraphQL API that I'll be using to feature this. But I'm just using plain old JavaScript because, well, I didn't convert it to TypeScript just yet because I want to show you first the pain that you actually experience when you try to rewrite something in TypeScript. So this is a JSX file. And actually today you don't have to do that much anymore to transport, or actually to create your project from JavaScript to TypeScript. At least with Create React app, we just rename this file to TSX, and then you should be fine. Of course, you need to add some time definitions, so probably we can do this pretty easy by just writing any for anything and see if our app keeps working. So let me restart it. I probably get some errors now in my terminal from TypeScript telling me I should change certain fields. So here they are. You can already find them here. So probably filter, I just need to give it a type. I can type any, but you can also say filter as a string. And GitHub Copilot is helping me with this, so it feels like cheating, but actually it isn't. And this way, this filter should be a string. And if you're working with JavaScript, you basically wouldn't know if this is a string or it's not a string. We should do the same thing for our use state hooks, because now you can see they're not typed. So, except for the number, because I have a default value. So I also need to add a type here. I could say it's any, because I don't really know what my data looks like just yet, unless I go to the GraphQL query. So this is my GraphQL query. From here I could find what the data looks like, but I don't really have to know. And then back down here, I probably have another issue. I would need to type the index. Let's just name it any, and name this any as well. So now my app should be working again. You can see all is fine. But I have typed any a couple of times because I don't want to feel the pain of typing all these things. So what I actually should be doing is I should be figuring out what my data looks like. So if this would be a REST API, I typically would need to send a request to the REST API and then figure out what the types look like. So probably my types will look something like this. So if I would be typing here, I would have a type called article. I probably define it as like an ID, which should be a string. Then maybe I have a title, which is a string as well. And you keep going like this. And maybe you start adding new fields. So maybe instead of the title, you also want a description. You want to get a username. If you need to be typing all these things by hand, it's pretty hard. You need to go to your API, figure out what the types are, and then figure out where to paste them in your code. Because now I have an article, but then actually my data there, it's probably nested because, well, I have a data object. Inside my data object, I have an articles object. And it's kind of hard to do this. I can probably type article here, and then I should be pretty far, but I'm still missing description. So if I would add description, I probably will be missing username and then be missing upvotes, maybe missing a URL. There are things that keep missing, and every time you add new things to your query, you will need to update this code, which is something I generally dislike. Because I'm lazy, as you see, I'm using GitHub Copilot for everything. We would get rid of this type. So what I will be doing instead, I will be using GraphQL Code Generator. And I already took away the pain of setting it up by creating a file here. So at the base of GraphQL Code Generator is your GraphQL schema. So you have a YAML file. I pretty much actually became a fan of YAML. I can understand most people aren't, but for configuration files, it's awesome. So I have my schema here, which is the GraphQL API. I told you I can define headers in case I have any. And then I need to point the code generator towards a file called operations, or actually my documents. So in GraphQL, whenever you send a request to the GraphQL API, you need to define queries. And these queries are something we saw in the graphical playground. But inside your application, you also need to define these queries. And usually you do this in a separate file. And in here you can just export them. And this way you can use them anywhere else in your code. So an example, I was using this query to get the articles. I want to get an ID, title, description, upvotes, all this other info. And I would define this operation in a separate file. Maybe you also define it inline, which is perfectly fine. But if you want to use code generator, you put them in a separate file. Because instead of just pointing them towards a file, I could also do this. Oh, this is by stars. You can imagine this probably will be slow because it will check all my TypeScript files and see if there are any GraphQL queries in there. So that's why I pointed them towards a specific operation. And now the only thing I have to do is actually running the code generator. So GraphQL code gen. If I run the CLI, it does multiple things. It first takes my GraphQL schema. It tries to find my GraphQL documents. And then it generates the TypeScript types for these documents. And it will put all this in a file that I call generated/types.ts. Looks like things are a bit slow, as the Wi-Fi decided to give up on me. So let me just restart this. So we'll be loading the GraphQL schema, we'll be taking the GraphQL documents, and then generate the TypeScript types. So let me check if the Wi-Fi is helping me a bit with this, or maybe it isn't. Interesting. So my GraphQL API is also not connecting. Well, I think the Wi-Fi doesn't like me. Maybe try the conference Wi-Fi instead. See if it's helping me a bit more. Run the code generator again and see if we actually get the types. This time it worked. So thank you, conference Wi-Fi. It's actually more stable than the venue one, which is great to see. So what it has done now, it took my GraphQL schema as a single source of truth. It parsed my configuration. It will find the operations I've defined in a separate file. And then it creates TypeScript types for me. So the first thing it does, it just maps the color types to whatever I like it to be. Then it creates the types for me. And you can see there are lots of maybes in there because GraphQL is optional by default. And TypeScript doesn't really like optional types, but I mean, that's fine because we live in a GraphQL world now. We're using GraphQL as a single source of truth. And all these types that are created for me, these are things I can use inside my home component. So whenever I'm trying to figure out what the type of article should be, instead of using any, I can just import the code that I have before. What we could be doing here is just import article from my generated types. And then this would just be the value of this thing. And then I can see there are some more issues. But these are things you can probably debug. Just finding out what your data is, where it comes from, and how it looks like. And the coolest part in this actually is if you're not using just a fetch request as I've done here, as I am a bit lazy, but instead use something called Apollo Client. Let me first quickly see how much time I have left. I think we should be fine. So what I will be doing instead of using just a fetch request, I'll be using Apollo Client, which even gives me more power because now I get a GraphQL client, which can also be hard-coded or actually strongly typed, not hard-coded. But in here, I'm going to define a query like this. I need to import use query from Apollo client. I think I commented out there. So I have a loading state, I have an error state. I can just delete this. And this should all work. What I typically do is see if you have maybe a loading screen. You can return something loading. And let's just neglect the error for now because, well, we're doing a demo anyway. So if I would be running this, it should probably still work. Maybe it doesn't. Let's see. No, because we're importing stuff we're not using, which is a cool thing because, well, this is we're also not using. So now my code is working again, but I don't have the power of the types just yet. So what I should actually be doing is also. So if I'm here, you can see this still isn't typed. It still says any. So with use query, you still will need to define the types we have. So what does it returns? It returns something of type data with articles, which are of type article. So looking at what I do in the rest of my application, my data would look something like this. I probably need to put this there. And then I imported this one here. Save this. It still says some things aren't really types because, well, I need to make some optional stuff. Make this optional, make that optional as well. And then it's still complaining because property articles doesn't exist. So maybe I don't really need this thing. I mean, it's still a hassle because this way we're generating the types, but we still need to figure out if something exists or doesn't exist. So it still doesn't completely solve my use case of applications of the future. So what I will be doing instead, something else you can do with Code Generator, and you can do this for basically every GraphQL client. If you would go to the website, you can find plugins for Vue, for Angular, for even if you're building GraphQL servers, you can still generate types. So what I will be doing, instead of going into the pain of trying to debug how my GraphQL client actually works, I will also be generating types for Apollo. Let me put this here, TypeScript, React, Apollo. If I would save this and just stop my application, the thing I can do now is, let me go into my generated file. You can see at the bottom, it only defined types for my queries. But what I also want, I want to have the GraphQL React hooks already there, so I can actually use them inside my app. And if we go down now, you can see much more has been generated. What it also generated for me are strongly typed hooks that can I use directly inside my application. So instead of importing the types there, the thing I would be doing is just importing my hook to get the information from my articles. So let me see what it looks like. I want to get use get articles, and then probably I want to get a list of articles. So it's probably this one. Yeah, I guess it's this one. So const loading and data. And in here I want to use this one. So let me see if I can get some help in importing it. Yes, I can. So update my import. And I run it like this. So now if I would be formatting this, you can see my TypeScript errors are gone. And actually every field along the line here is typed. And I didn't need to figure out what my data looks like, where it comes from. The only thing I need to know is that I'm using a query to get articles. I've defined all my queries in this operation file. So looking back at the previous talk we saw about clean architecture, I think this is a a nice example because you separate all your queries from the rest of your code. And inside the code, the only thing you're doing is just getting information. You don't even need to add TypeScript types anymore because everything is generated for you. So it's quite an easy way, I wouldn't say easy, but straightforward way to get TypeScript types for a React application without having to figuring out the pain where your data comes from, what it looks like, and how you should structure it inside your app. So this was the demo. We used some React application. We used GraphQL code generator to create the TypeScript types for us based on the GraphQL schema. And in my opinion, this is pure magic, especially if you understand the pain. If you work with TypeScript, you work with REST APIs, or maybe even GraphQL APIs, and you try to figure out what your data looks like on the front end. Of course, you can use the schema, you can use the result of your REST API endpoint, but in the end, it's just better to create the types for you. As you saw, it saved a lot of code, but it also saves you a lot of nightmares and hard pain while debugging code. So maybe if you're not using TypeScript or you're not using GraphQL, the question is, should you actually be converting everything to TypeScript right away? I think you shouldn't, because this looked easy, but try to do this on a code base with maybe 100 components. I mean, things will just collapse, and probably you'll figure out that all those things you've built maybe aren't as stable as you imagined when building these. So try and convert the JavaScript app to TypeScript, and you probably see this. But in the end, the results will be great. It maybe take you a week, maybe take you days to convert your application, but in the end, it will save you a lot of time and trouble. So whether you start using TypeScript, yes or no, if you start using GraphQL, yes or no, you should definitely start using type systems inside your applications, because it will just save you a lot of pain in finding out what your data is, where it comes from, and what it looks like. So if you like this talk, I actually have a small favor for you to ask. And I'm not hiring, but instead, I was nominated for some cool awards for Hacker Noon. So if you are reading articles on Hacker Noon, feel free to scan the QR code and show your support. I was nominated for Software Developer of the Year and also GraphQL Contributor of the Year. So actually how I got into speaking was creating blog posts on Hacker Noon, on Practical Dev, on Hashnote, and all the different blogging platforms out there. And somehow it ended up in being awarded for something. So it could be nice to win something for a change. Usually I just lose at the lottery or the casino, but maybe I have more luck here. So thank you. I hope you enjoyed. I hope you start using a type system inside your applications. If you have any questions, I'll be around all day and maybe even this evening at the after party, or just send me any of your questions on Twitter. Thank you.